Hello. The purpose of this video is to show you guys and try to explain superheat and subcooling temperatures. And if you need to during the course of the video, if you want to take notes on some of the text slides, feel free to just pause it and it should resume when you hit play again. Okay, let's get started. Alright, so subcooling is the cooling of a liquid below its condensing temperature. And superheat is the heating of a gas above its boiling temperature. So we need to know superheat and subcooling to properly determine how much refrigerant is in the evaporator and the condenser in the refrigeration system. Okay, so if we follow this kind of rough diagram I drew up, the refrigerant is entering at the top right hand side. And at that point, what it's doing, it's coming in as a high temperature, high pressure gas from the compressor. And the pressure of that refrigerant is 120 psi, as indicated at the upper right hand corner. As it comes in, finally at point A, it starts to condense into a liquid refrigerant. And as it's condensing, we're rejecting a lot of latent heat to the ambient air. So it continues on through the condenser, and finally it gets to point B. At point B, it ends up being 100% liquid. It's still 98 degrees right at that point. It still has to continue through the condenser. Now it's all liquid. And as it works its way towards point C on the outlet, which is actually the liquid line of the condenser where it comes out, we keep rejecting heat to the ambient air. At this point, it's sensible heat. Okay, so let's go through it. So if we look at the diagram, we can see that we had a high side pressure of 120 psi. Point A, the condensing temperature equals 98 degrees. And to find that, all we use is a PT chart to convert that high side pressure to temperature. So at point B, the condenser contains all liquid. So what happens is, as it continues to travel through the condenser, it's going to lose sensible heat to the ambient air. At point C, the liquid refrigerant has finally left the condenser and is now in the liquid line at a temperature of 84 degrees. So the steps to actually calculate the subcooling, is we have to read high side gauge pressure, which is 120 psi. We convert this reading to temp with a PT chart, and it comes out to 98 degrees. Measure the liquid line temp, leaving the condenser with a thermometer, and we get 84. So we have to subtract that 84 degrees from the condensing temp, which was 98. So 98 minus 84 equals 12. So the subcooling is 12 degrees. Alrighty, now we're going to look at evaporator superheat. It's kind of a better diagram because I had a little more production value to it. So anyway, if you look to the bottom right, what's happening there is refrigerant is entering the evaporator by way of the metering device. When we get to point A, it's actually turning from a liquid into a gas, so it's boiling. And that boiling temperature is 23 degrees. And I figured that out because on the upper right-hand side, there's a gauge pressure of 20 psi. I just converted it. That's how I figured out my boiling temp. So what ends up happening, that refrigerant travels through the evaporator all the way to point B. And while it's going between point A and point B, it's boiling. So it's absorbing heat from the cabinet. Finally, at point B, it's all gas, but it's still going through the evaporator coil. And as it goes through the evaporator coil, it continues to pick up heat from the cabinet. So as you can see, as we start traveling from point B to point C, which is actually the suction line where it exits the evaporator, we continue to pick up heat. Alright, let's take a look now one last time at how that process works. So once again, calculating superheat. So right now we read low side gauge pressure, which is 20 psi. At point A, the evaporator boiling temperature is 23 degrees Fahrenheit. And I use that PT chart just to convert 20 psi to temperature. Point B, at this point, all the liquid refrigerant has boiled off to gas. As this gas continues to travel through the evaporator, it continues to pick up heat, which is sensible, from the cabinet. At point C, the vapor refrigerant has left the evaporator and is now in the suction line at a temperature of 33 degrees Fahrenheit. So we know that information, and the steps to calculate superheat It's simple. We read low side gauge pressure, 20 psi. We convert this pressure reading to temperature, which is 23 degrees. And then we measure the temperature of the suction line leaving the evaporator with a thermometer. And that's 33 degrees. Subtract the temperature of the refrigerant leaving the evaporator, that's 33 degrees Fahrenheit. So we're taking out 23 degrees from it, and that equals 10 degrees Fahrenheit. Our evaporator superheat is 10 degrees Fahrenheit. Okay, so this brings to a close the Superheat Sub Cooling video. So what I want you guys to do now is to try to do those two problems I gave you. Just follow the instructions on this video and see if you can make it make sense. All the calculated temperatures and pressures we went over in class already. So now all I want you guys to do is to figure out the superheat and subcooling. Superheat and subcooling calculation temperatures, we'll go over that at another point. Okay, so just try to figure out the actual superheat and subcoolings on those examples. Okay, and I look forward to seeing you guys in class on Monday. Thanks.